Welcome back to the channel. So in the last episode, I got out my old AT&T Trimline 210 telephone, and I took it apart and discovered the chip that's inside. Then I ended up talking about the 3 chips in the SGS Thomson MK537X series of chips. These are what I like to call Trimline-On-A-Chips. I define that term as the integrated circuits found in the trimline phones of the 80s and 90s that consolidate all of the convenience features into one place instead of having discrete logic. And so those features include touch tone dialing, pulse dialing, keyboard decoding, speed dialing, redialing, all of that stuff. Well, recently I went to a ham radio convention and picked up this $10 box with 2 telephones in it, 2 trimline phones. And so in this video, I'm going to be looking at some of the other Trimline-On-A-Chips found in other phones, not made by SGS Thomson. So this one right here is a Unisonic 6012X. And it is a much simpler phone than what we were just looking at. This one has the hook switch right here. It's got the ringer built in. And this is the base. It has no electronics. You just slide it in there, and by sliding it in, it pushes that down. So you still need the base in order to properly hang up the phone, although it's actually flat enough that you could set it down on the desk and I suppose it would hang up, but not a very reliable method. Well, anyway, I went and picked it up and pushed one of the buttons. And it's doing pulse dialing. So I thought, well, that's fine and dandy, but where's the switch to change it to touch tone? Aha, it doesn't have touch tone. It's only pulse. This thing is so cheap that it only does pulse dialing, despite having a touch tone pad. I suppose it was new enough that, well, you wouldn't want to be caught dead making a phone with an actual dial on it. We got to have number keys. But it was old enough that it was during a time where I suppose a cheaper option would have been to only have pulse. I mean, most telephone networks at the time supported pulse, so it's not like it made that big a difference. So this thing is a pulse-only phone. It has a redial label right there. I can't figure out how to use it, but other than that, I mean, you just pick it up and push the buttons, and that's about all it does. So, cracking it open, we have right here on this older looking analog board than what we were just looking at, the UMC UM9151. And that second line down there says 8325. If that is the date code, then that means that it was made in the 25th week of 1983, which seems to check out. And you can see right here we have a broken resistor, but it doesn't appear to affect functionality, so I'm not going to do anything about it. So this UMC 9151, here's the data sheet, and it is in fact a pulse dialer. It only does pulse. It's not like it does touch tone and they didn't include a switch for it. It only does pulse. And some of the features include direct telephone line operation. Well, obviously it's meant to control a telephone. 4x3 matrix single contact keyboard. So it uses the same matrix system as the other chips, but it doesn't even have support for a 4th column or 4th row or whichever it is. It's just these typical 1 through 0 star and pound. Voltage supply range from 2.5 to 5 volts. Inexpensive RC oscillator. Low power standby mode for redial. And 22-digit capacity for redial. So it does have a redial capability, if only I bothered to read the manual and figure out how that actually works. And I was curious about the oscillator, so it turns out that it doesn't use a color burst crystal. It actually just uses a sort of RC oscillator. If you want, go look up the data sheet and it explains it more, but it runs at 18 kilohertz. Now, I would argue that this would also be considered, under my definition, a Trimline-On-A-Chip, because even though it is just a pulse dialer, it's got a redial memory and it's got the ability to read a keyboard, so it's just a much simpler one from an earlier time and a cheaper phone. So this is a TPS model TL-10B. I don't really know who TPS is, but I'm sure that means something to somebody. And it is a pretty common looking trim line. It's got pulse, it's got tone, it's got some amount of speed dial memory, it's got a redial that doesn't seem to do anything, it's got a pause button, I think this is a flash, no volume controls or anything. And the bass, I don't know if you can hear it when I smack it, but it's got an actual bell in it. Not that our fiber modem puts out 90 volts AC anymore, so it's not like I can hear it. So here we have a very analog looking board, and there is the chip, a Spica SA2-585C. Now I've looked and I've looked and I've looked again, and it seems the internet doesn't even know this thing exists. I can't find anything about this chip, so it is as good as proprietary. But I can assume that it has the typical features of a Trimline-On-A-Chip, including, wouldn't you know it, a 3.579-545 crystal oscillator. I will say that the chip in this might be a little more advanced, kind of, than what we have in the Trimline 210. If you listen to it, when I push a tone, sounds more like a modern telephone, whereas when I plug this in, it almost sounds kind of like this one uses square waves and that one's a little more sine wave like. So I've run out of telephones to show off, but there is another chip I'd like to talk about. This is the Texas Instruments TCM 5089N. It is not what I would consider a Trimline-On-A-Chip. It does have the rows and columns for support of a keypad, but other than that, all it does is DTMF. Has no memory, has no special features, no timing. It just converts the keypad to tones. And I guess in theory, if you wanted to make a really simple handset, you could use them. I got these because I figured, you know, if I'm going to build some DTMF circuits, instead of trying to get the slightly harder to come by Trimline-On-A-Chip architecture ICs, I should just get a dedicated chip that doesn't have all the extra features I don't need. So I got 5 of these. The last thing I got is 6 Mytel, Mittel, whatever, MT8870 DTMF decoder chips. These things take an audio signal and turn it into a binary number to tell you what's on the line, what DTMF codes are being pushed. These are also not out of any particular phone system, they're just dedicated decoder chips. But if I'm going to have encoder chips, I'm going to need a way to decode them, so that's why I got them. But I think that's going to be it for this video. I don't have any circuits that I built to show. I might in the future, but we'll have to see. But thanks for watching, and I'll see you in the next one.